This is really a tour of the geology of southwest United States. And we're going to start from the west, starting over Morro Bay, Big Sur, and we'll work our way over to Arizona. Southern California, Southern Utah, and Arizona. So these are all places that you can go and visit. All of them are within a day drive. We have our field classes, which are offered every semester. And so we go up to Big Sur. And by the way, this is from Ragged Point, that's the fastest rising mountain range in the world. It's rising faster than the Himalayas. Okay, and we also visit other places on our field trips, like this is Salt Flats and Carrizo Plain. Has anybody here been to Carrizo Plain? It's an underappreciated, it's a brand new national monument. It has like a little visitor center open 3 months out the San Andreas Fault. And what it's happening here is we're looking straight down the fault, where all those bushes are, is the San Andreas Fault. You can actually stand, we have lunch, and people have lunch, and they could have like 1 foot in North America plate, 1 foot on the Pacific plate, and that was sort of fun. This is getting down and looking for minerals. Okay? And what we're looking for, we're on Moonstone Beach, but we're not looking for moonstones, because that's totally picked over. Doesn't it? What we're looking for here is jade, and you can get little jade pebbles. And so everybody, all these people on their belly here at sunset. So our first student here is Nicanor Bautista. He's one of our newer geology majors, and he is going to spend just a few minutes talking about this amazing place called Morro Rock.
What my presentation will be on how Morro Rock was formed. Morro Rock is located in Morro Bay, near San Luis Obispo, about 3 hours northwest from here. During the fall of 2011, the Geology 34 lab had a trip to visit Morro Bay. And how many have you been to Morro Bay? Raise your hand. So you guys like it over there? Yeah.
Like ours.
Pliocene time, about 15 million years ago, there was some eccentric fault started to rip California apart. You can see here. At the same time, there are some extension that was caused by normal faults. Some magma flow in cracks and start to form a volcano chain. There are 12 volcanoes in the chain that goes from San Luis Obispo, like over there, to Morro Bay. Morro Rock was forming a volcano as a volcano neck. See right there, volcano neck between. A volcanic neck is a hardened rock in the band that did not erode when the rest of the volcanic eroded.
This one particular one, we went out to the National Association of Geoscience Teacher Conference. In fact, we sponsored something. We went up to the Kelso Dunes. Has anybody been to the Kelso Dunes? Oh my gosh, they are the best. And they're like 3 hours away from here. And they are the tallest sand dunes in California. And they're a lot of fun. When you go to Kelso Dunes, you have the choice of crawling up here, walking up to the top. And this is like hundreds of feet high. And then what do you do when you're on top of a dune?
Jump off.
You jump. So we have lessons in jumping. Okay, so this is Skip, who you'll see tonight. So but this is just proof that geology can be fun. So this is the kung fu way of jumping or something like that. One thing I got to mention, though, these dunes you shouldn't just jump off, because if you walk down them, you hear the growl. They're called growling dunes or barking dunes, and only certain dunes do that. There's some in Hawaii and there's the Kelso dunes, and it's only if those sand grains are really, really round. They've been through the mill like 2 or 3 times. Okay, and then this is June teaching me a new way of jumping. I don't know. So, okay, we have lots of cinder cones. We got them in south of Baker on the Kill-Baker Road. There's a whole bunch of volcanoes. And to tell us about some of this is Skip.
Afternoon, folks. How we doing today?
Hey,
Rocks, right? So, I'm here to present cinder cones by me. 4 marvelous fun facts about cinder cones is that, 1, they develop rapidly. Nice little fun fact for you, there was Little crack in Mexico in, I think 1949. In 9 years, it developed into a 1,000-foot cinder cone. So they developed really rapidly in comparison to shield or composite volcanoes. When gas forces steaming lava upwards into the air, as it cools, when it falls to the ground, it converts into pebbles, or cinders as scientists call them. These build up around the vent, they ejected them, forming a cone, and giving this type of volcano its name. We see lava tubes formed by cinder cone volcanoes. Some lava tubes you can come out and be reborn again, as you can see. As you can see here, globs that are airborne and are 2.5 inches in diameter or bigger are called bombs. And here we can see bigger bombs here. I just have a football. No, the tail usually comes attached. When it goes up in the air, it leaves a trail, and when it comes down, it breaks off like a tadpole. It usually goes like that when it comes down.
Okay, next we want Angela to come up, and she's one of our newer geology majors too. And
I am just going to give you a brief run-through about what we did when we went to Anza-Borrego. We went to the Salton Sea was one of our stops, and we went to Shell Reef and got to see fossils, which are, by the way, up here. If you'd like to see it, there's a big chunk somewhere. That. With all kinds of crazy fossil oysters. The most incredible thing by far for me was getting to see the wind caves. And I was even more amazed by how the process works. What happens to form these is sand gets blown off of the Badlands and gets thrown onto the surface of these sandstone structures, and slowly gets trapped inside of the cracks that are exposed and gets spun around for years and years and carves these gorgeous alcoves and outcroppings, and everything here that you see was caused by the wind just doing what it does best and blowing stuff around.
okay, so the next talk we have is about the mud volcanoes, which are nearby there. They're just beyond Anza-Borrego, but it's much easier for us to get there. You can go by freeway almost the whole way if you know how to get to Salton Sea. And to present this is one of our newer geology majors, is Sammy Ramos.
Last month, Geology 32 Lab took a trip to Anza-Borrego, and one of the stops was the mud volcano. Mud volcanoes are formed when hot water and mud are mixed in the earth, and as you can see, this magma chamber here heats up the water reservoir, and it turns into a gas or steam, and then it pushes up to the mud pool, which causes bubbles. These bubbles they're caused by methane, and this methane is really smelly. So when you go visit them, it's really stinky. So the difference between a mud volcano and a regular volcano is the magma doesn't really rise. It's basically just a bunch of gases and water trying to escape. As you can see here, the methane is trying to escape, so it like pops up and just spreads everywhere, and as it dries, it's sort of like, if you feel over here on the side, it's very clay-like and siltstone-ish. And something fun I got to do was dip my hand into a mud volcano liquid, and it was really hot, but most of them can run up to 100 degrees, so that was pretty.
We went on a big, huge science club trip. It was, as I already explained, it's mostly earth science students, and they're a very active club, one of the largest clubs on the campus. And thanks to the generosity of the South Bay Area Mineral Society, they had a fundraiser at their mineral show last month and raised about $200, and a lot of you were generous in your donations. Bryce Canyon was one of our high points. In fact, they voted that their #1 spot. How many people have been to Bryce Canyon? All right, see, almost everybody. I knew it. And it's an awesome place. Even our vice president of our college showed up. All right, next on our thing here, we went over to Zion.
How's everybody doing?
Hey.
Awesome. As Joe is nice enough to point out, my name is Ian Walker. I'm a geology major at El Camino. I am an officer in this science club. And the science club went to Zion on April 9th and 10th of this year. Has anybody been to Zion? If you were there, you probably noticed the cross-bedding, which is what I'm going to talk about today. Yeah, that's the cross-bedding there. It's called cross-bedding because it cuts across the normal horizontal bedding or layers. The formation is basically from wind-blown sediments and sand of varying colors, types, and compositions, different minerals. They accumulate in thin layers and they build over time. What happens is it eventually will reach the angle of repose, which is the maximum angle that sand can hold itself up. And what will happen is a mini avalanche will occur and the sand will travel down the backside. It's about 30 degrees, the angle of repose. And what happens then, after the sand dunes are formed, calcium-bearing solutions end up seeping into the sand, and it cements it together, creating the Navajo sandstone, which has a very red color, which is indicative of formation in a dry environment where the irons in the sediments has been able to oxidize over time. Using these tools, we can determine the direction of the sediment transport as well as the way the winds were going. From this information, geologists have been able to determine that about 200 million years ago, the southwestern United States was covered in a large desert, including parts of the Grand Canyon. Who's been to the Grand Canyon? Awesome. There is a little bit of cross-bedding in the fossilized dune formations in the upper wall of the Grand Canyon. It's actually the second layer down, so look out for that. It's called the Camino Formation. There it is, the second layer down. It's a great tool for geologists to determine the geologic history of an area, to be able to put the puzzle together basically, and to tell what happened in the past. It's also something really cool to look at, so get out there if you have a chance.
The Grand Canyon, and it was so big, we got the school newspaper, okay, to help talk about us, the Grand Canyon. To tell us about the Grand Canyon is another brand new geology major. This is Jerry Hernandez.
So today I won't be talking about the layered deposit of the Grand Canyon. I'll be talking about the formation of the Grand Canyon. And two of the main concepts that go with the Grand Canyon are stream capture and headward erosion. And they sort of go hand in hand in this case. And you can't have one without the other. So this here is a map of the Grand Canyon. This is the Grand Canyon. This here is the old Colorado River, which then eventually diverts into which one is now the Grand Canyon. This is the present Colorado River, Little Colorado River, as you can see. So let me just give you a quick definition of stream capture. Stream capture is also known as river capture. It's a geomorphological phenomenon that occurs when a river or stream diverts from its original bed into the neighboring stream. And how does this happen? It happens with headward erosion. So headward erosion is a river process of erosion that lengthens the stream or gully at its end. And this is the uphill end. That's where, and enlarges the drainage basin. This is the drainage basin here. And I'll show you a little bit. So basically this stream here, it just started digging little by little until it reached the Colorado River, and then it just snatched it from its original bed. And that's that concept is what interested me in giving this presentation today. I believe convergent plate boundaries caused this Kaibab Plateau, which lies on the Colorado Plateau, to uplift. So instead of the normal convergent boundary plates to go down into the earth, it went through Earth's crust, which lifted it, causing this plateau to uplift. This whole Colorado River used to run down this way, but then when it was snatched, it changed its direction, and then Little Colorado River now falls into through the Grand Canyon as well. How long did this take, you might ask? It actually took about 5 million years, which is very rapid in geologic time. The rate of vertical erosion was about a foot every 1,000 years, or 1,000 feet every million years. If
you're going to go to the Grand Canyon or anything around there, you've got to go that extra half hour and make it to Meteor Crater. One of the world-class things that we have in southwestern United States, we have everything here. This is the best place. This is why I moved 3,000 miles to teach geology here. We have everything. And this is the farthest one away. This takes about 9 hours to get to. But to tell us about this is John Burton.
I'm a geology and astronomy major. My career goal is to become an astrogeologist. I love to study other planets, so naturally this would be of great interest to me. Now, I know a lot of you obviously have been to Arizona. How many people here have been to Meteor Crater? Okay, so a good number of you. Many people, when they go here, it's really just a big hole in the ground, but when you take a little time to learn about it and start to look at features, it's actually quite fascinating. This is the first crater on Earth that was actually recognized as being of extraterrestrial origin. Everybody before this time thought they were formed by volcanoes or steam explosions, but this is where an asteroid struck the Earth. But 50,000 years ago, a nickel-iron meteorite struck the land. And the size of the asteroid was about 150 feet across. But when it hit the ground, it hit with nuclear force. It hit with about the energy of 150 Hiroshima A-bombs. And what it did, rather than burrow into the ground like many people would logically assume, there was so much energy involved that it literally vaporized the majority of the meteorite. And so when you go to Meteor Crater and into that area today, you actually find very little meteorite material. Most of it turned literally to vapor and shock waves went through the ground and it threw material out for a distance of about 6 miles. This is a cross-section, a side view of the crater. The crater is about 3/4 of a mile across, and this was the original hole that was gouged out by the meteorite. And that was about 800 feet deep. But when it threw the material out, it also threw a lot of material straight up into the air, and that just fell right back down into the hole, and it filled it in, actually, again, within moments, about 300 feet. But erosion over the last 50,000 years has also filled in a very thin layer, it's called alluvium, here in the crater itself. So that added about another 200 feet of depth. So today it's only at 550 feet deep. So when it exploded and it threw out that material, it took these layers here and it bent them upward. Now this green here, you'll see a little line right there. That's called a hinge. These layers here were actually flipped over completely backwards. When you go to the crater today, it's actually kind of difficult to see. But one of the biggest proofs that this was of a meteorite or impact origin is what's called rock flour. And if you were standing there on the rim and you were to grab some of these rocks, you can pick them up in your hand and crush them literally into flour. And that's because it was pummeled by the energy of the impact. Well, why is a place like Meteor Crater so important to science? And so the Earth, as well as every other planet, formed through this process of accretion. We have erosion, so we only have maybe 200 or 300 recognized meteor craters on Earth today, but if you look at the moon, and I'm sure most of you have seen it through a telescope, maybe at Griffith Park, it's covered in craters. And so when we study this, it's a key to understanding the origin and evolution of the solar system, but also our home world. So,
he was talking about astronauts using these as landing, so that's a perfect segue to my last thing I want to conclude on, and that is our most famous geology graduate is an astronaut. He's really well known. His name is Michael Fink, and he remembers fondly going to Anza Borrego and Death Valley with me and the other teachers and stuff. And one of the things he was showing is that when he spent an entire year in the space station in 2 6-month segments. And one of the things they get to do is bring up their own stuff. So, yeah, tours, opening, like that. So this is him floating around in outer space.